We have so far understood when you have two charges, what is going to be the net force that's going to exist between those two charges. Now, supposing you want to find out what is the amount of force that any particular charge is going to produce, right? So that is defined as the force due to or the field due to that particular charge. That is what is known as the electric field. So let's try and understand about what exactly does an electric field stand for. So what exactly is an electric field? When we talk about an electric field, it is the area around a charged particle in which the forces of attraction or repulsion are noticeable. For instance, if you remember in the Coulomb's law, what we said that the force is equal to K Q1 Q2 upon R square, right? So if I say one of the charges is unit charge, so I can just put it as F by Q1 either way. So that is going to give me K Q2 upon R square. So this is the influence of the particular charge Q2 anywhere at a distance R. If I just take the magnitude, not the direction. So this is how we define the electric field. Okay. Now going further, what exactly does electric field stand for? So it is nothing but the vector field associated with the presence of electric charge. That is what is known as the electric field. Electric field is the influence of electric charge on space or the medium itself. Then the direction of the electric field is determined by the direction of the electric force, because you can have the influence existing everywhere along all possible directions, but you can only find out the force only when you have the two charges, because the force is going to exist between the centers of the two charges. So if you put a positive test charge at a particular position, join the centers of the two charges, that's going to give you the direction of the electric field. Now what exactly are the electric field lines? When you because you just have one single charge, by convention we say that from a positive charge the field lines are going to go out, and from the negative charge the field lines are going to go in. Right? So here, as you can see in the diagram, you have negative charge, the field lines are going inside. Similarly, if you have positive charges, they are going to repel each other. So electric field lines, these are defined as the electric field lines as a path which can be straight or curved, such that if you draw a tangent anywhere on those electric field lines, that is going to give you the direction of the electric field intensity at that point. Electric field intensity means how much is the amount of electric field that is there at that particular point. Yeah. Now, one thing to note here is that no two directions of electric field can intersect. If you have two electric field lines intersecting, that means there are going to be, if you draw a tangent, there are going to be two directions of the electric field. That is not going to be possible. At any particular place, you cannot have two directions of electric field. These are vector quantities, so there is just going to be one single direction, right? So, the important points here. Tangent to the electric field at any point gives the direction of electric field intensity at that point. Okay? No two lines of force or electric field can intersect each other. Electric field lines are always normal to the surface of conductor. For instance, if I say that this is my conductor which has some charges in it, the electric field lines are always going to be produced perpendicular to it. It may not be looking like that it's going perpendicular, the surface itself is looking kind of crooked. So, but the electric field lines are always going to be normal to this particular surface. They're not going to be tangential, mind you. The electric field lines contract longitudinally. The electric field lines exert a lateral pressure. They're going to be exerting a pressure in the outward direction. So these are the properties of the electric field lines. So stay tuned for further on this particular chapter.